everybody, Mr. Mack here. I'm going to do some of the practice set from 3.6. We are using the distance formula here, among other things. And so let's get started. So what is the distance formula between 2 points? So the distance formula is the square root of the difference of the x's squared plus the differences of the y's squared. And this is derived from the Pythagorean theorem that you guys saw in the notes. So it's important to label the coordinates and put them into the formula correctly. It's not a difficult problem to do, just crunching the numbers, but got to put the right ones in. So -2 is my x2, it's the second point, the x-coordinate of the second point, minus 4 squared. Okay, 4 is my x1. y2 is -1 minus 15 squared. So just follow the order of operations. We've got to do everything in the parentheses first. And let's see, -1 minus 15 is -16. That's a plus squared. Okay, so this is going to be, so a negative squared is positive, it's 36, and -16 squared is 256, and so let's add that together, and we're going to get 2, 1, 9, let's see, 5 and 8 is 9, and a 2, 292. We're rounding to the nearest hundredth, so now we have to take the square root of this, and that gives us, and if I could punch it in the calculator, 17.0880. So rounding to the nearest hundredth. Here's the hundredths place here. So D is going to be 17.09 is the solution. So x2 minus x1, plug that in, -2 minus 4 is -6, 36. -1 minus 15 is -16 is 256. Add those together, we get 292. We take the square root of 292, and we get 17.09. All right. So number 3, you can follow the same pattern here, the same steps as number 1. Number 5, we've got points that are plotted on a coordinate graph here. So we are trying to find this distance between A and B. So like I said before, this is derived from the Pythagorean theorem. So we're finding the difference in the x values. So this is the change in x, and we're squaring that, and then the change in y, and we're squaring that, and then we're taking the square root of these added together to give us this side right here. So if we know a squared plus b squared equals c squared, we can solve for c, which is the hypotenuse. So the d in this case is the same as the c for the hypotenuse of the right triangle. but we are just using the distance formula in this case. So really this is the same steps that we did before. We just have a little bit more of a visual. And we can kind of take a guess, estimate. So this is 3 and this is 1, 2, 3, this is 4. So, how long is this? Looks like maybe around 5, right? So let's put everything in. Let's label this point. We're at 2, 2. And this one down here for A is -1, -2. And this is x1, y1, x2, y2. So, and maybe I shouldn't have, you know what, let's reverse this. Let's back this up. Let's make the A point the x1, y1, and then the B point the x2, y2. It doesn't matter, but I think it's easier to say that B is the second point. Okay, x2, 2 minus a -1 squared plus y2, 2 minus a -2. Watch the double negatives here. So the difference of the x's here is 3, isn't it? This. So look, 2 minus a -1, that's 3. 3, and we're going to square that, plus difference in the y's, see that, is 4. So we got 2 minus a -2, that's 4. And we're going to take the square root of that, so this is square root of 9 plus 16, square root of 25 equals 5. Plus or minus 5, but we throw out the negative. This is a positive 5. Okay? So we didn't have a decimal to worry about in that one. Okay, 8. Find the distance between the point and the line. Okay, so the shortest distance from a point and a line is going to be a segment that is perpendicular to the line. So if I put it down here, just think, oh, here's 5 and this line's at -5, and just go, oh, that's 10 units. That's not the shortest distance. So the shortest distance is going to be more of an angle here to make this 90 degrees. If you see right here, this angle here, this is not 90. All right. So how do we get a 90? So what we're going to do is we're going to take a look at the slope of this line right here, the slope of this line. And then we know that perpendicular slopes are negative and reciprocal. Negative and reciprocal. That's what we did that last section. So let's find a point here. How about right here where we see 5? And where's the next place where it hits the graph? Right there. So we are going down 1, and then we're going over 3. So this slope right here is -1/3. So a perpendicular slope is, we're going to make it positive, and we're going to take the reciprocal of that. So that's going to be 3 over 1. So let's start at A here, and let's go 3 over 1. So if I go up 3 and over 1, I'm off the page. So we can also go -3 over -1, because that is the same as a positive 3 over 1. So that means we're going to go down 3 into the left one. Boom, right there. Down 3 into the left. down 3 and to the left. And look, we're right on the line. That's nice. And we're going to make a segment. And there we go. We need to find this distance. This is the shortest distance, D. And I need the right tool to draw. Right here. We're going to find this distance. So what do we need in order to use the distance formula? We need 2 points. So we can get our x2 minus x1 squared plus y2 minus y1 squared. So let's label them. Let's call this B right here, point B. So A, we're at 0, 5. And this is our first point, so I'm going to call this x1, y1. And B, we're at -3, -4. Third quadrant. And this is x2, y2. Let's put it in. So -4, sorry, let's get my x's first. We're doing x2 is -3 minus 0 squared plus, okay, y2 is -4 minus y1 is 5 squared. So the difference in the x's here we can see is 3, and the difference here in the y's we can see is 9. See that? So this is going to be a -3 squared plus a -9 squared. Alright, so this is going to give us 9 plus 81, which is the square root of 90. If we wanted to put this in simplest form, simplest radical form, we know that 90 is 9 times 10, and 9 is a perfect square, so I could take that out. The square root of 9 is 3, and then I leave the 10. But if we want to find the decimal, of course we have to round. We get 9.486. 9.48487. And then if we're rounding, I don't say, so if we're rounding nearest hundredth, this would be, our distance would be 9.49. So it's about 9.9 and a half. So it's not quite 10. 10 would have been straight down, but this is shorter. Shortest distance. Okay. That one's done. And so 9 and 11 are the same kind of problem as we just did. It's the same problem. You just got to do a little more work. So for number 9, we got to graph this line. So this is already in y equals mx plus b form. So m is 1/3, b is 4. So we're going to go up 4, and then we're going to go from there up 1/3, up 1/3, and we have our line. Now for our point, we're at 5, -1, right there. We're in the fourth quadrant. Let's call this A. and we're at 5, -1. So again, the shortest distance from a point to a line is a segment here that is going to be perpendicular. So we know the slope of this line already. So the perpendicular slope is going to be negative and reciprocal. So the negative reciprocal of 1/3 is -3/1. So that means we're going to go down 3 and over 1. We've gone off the chart again. So the other thing we could do is we could say, okay, this is the same as saying 3 over -1. So instead of going down 3 to the right 1, we can go up 3 and to the left. Up 3 and to the left. Boom, we're right here. There's our intersection, and we're going to draw our segment, and we're finding distance right here. And so that's A. We can call this point right here B, which is at 3, 5. And then we've got our distance formula. Differences the x's squared, differences of the y's squared. Label your points. We got this one is x1, y1, x2, y2, and just put it in. You can do that part. Already shown you how to use the distance formula. Same thing with 11. Graph the line, plot the point, find the negative reciprocal for the slope. Okay, 14. What happens if we have two parallel lines and we want to find the distance between the lines? So the idea here is there are many places that we could check. Okay, if we are, say this is a road and we wanted to cross the road, it doesn't matter where we are. If I am here and I want to cross the road, I'm looking to go perpendicular to both lines. Or I could be over here and I'm looking to go perpendicular to the lines, so to be the shortest distance. But all of these would be the same. There are infinite number of segments that would work. So let's just find one that would be easy. So there's no wrong one, but there's some that might be easier than others. Let's say this point right here. So this point is at 1, 0, and would be the matching point on the other line. Okay, so let's check the slope. The slope of this line is down 1 over 2. So this slope is down 1 over 2. The slope right here is also down 1 over 2. So what would be the negative reciprocal of that? Perpendicular slope would be 2 over 1. So now from here, if I go up 2 over 1, up 2 over 1, there I hit the line. And I can use that. I could find that distance right there. So this distance here is what I'm looking for. Let's label this point B. And this is 3, 4. And again, we can call this point x1, y1, and this one x2, y2, and then we can find the distance using the distance formula. You guys got that? So I've set that one up, and now you can knock it down. Alright, I'll do one of these here, 23. Find the equation of the perpendicular bisector for a pair of points. Okay, so what does a perpendicular bisector do? It intersects a segment at the midpoint at a 90-degree angle. So let's find these 2 points. One 5, and 7, negative 7. So maybe I'll label these A and B. And let's make we'll go with teal. Now, so we got to find the midpoint of these two segments. Let's use the midpoint formula. Starting to get several formulas here that you're going to have to keep straight. Slope, midpoint, distance. The midpoint formula is x1 plus x2 divided by 2. We're taking the averages of the x's and the average of the y's. So x1, y1, that's our A point, x2, y2, that's our y. Let's put it in. So 1 plus 7 over 2. Okay, these are our x's. And we've got 5 plus negative 7 averaging our y's. So 1 plus 7 is 8 over 2. 5 plus negative 7 is negative 2 over 2. 4 and negative 1. So over 4, down 1, here we are right there. It better be on the segment. If you're not on the segment, then you made a mistake somewhere. So now we need to make some sort of line here that's perpendicular. So this line is going to be perpendicular to this segment. So what do we need to do? We need to look for the slope. Now I called this M right here for mid. How about I just say mid like that? Because now the slope also is an M. So this is slope. And the slope is going to be the rise over run. Which is the change in y's over the change in the x's. You don't have to memorize this stuff. I mean, midpoint is in the middle. That's an average. You guys know what an average is. Okay, rise over runs, the difference in how much we go up over the difference how much we go over. Okay, that's subtracting the values. So y2 is negative 7 minus y1 is 5 over x2 is 7 minus 1, and this gives us negative 12. So what does that mean? That we're actually going down 12 units. We count all these as 12. Boom, to 12. And then we are running 6. 1, 2, 3, 4, 5, 6. That's what that means. We can see it visually right here. So that is negative 12 over 6 is negative 2. Or negative 2 over 1. Now, we need the perpendicular slope for this line is going to be the negative reciprocal, is 1/2. So let's go from our midpoint. Let's go up 1 over 2. Up 1 over 2. Or we can go down 1 to the left 2. Down 1 to the left 2. Let's make our line. Just like that. Now we need the equation. So the equation of a line is y equals mx plus b. M, we already have. There's M. B is where the line crosses the y-axis, and it crosses at -3. So the equation is y equals 1/2 x minus 3. And that's it. Some work here, okay? Midpoint, slope, negative reciprocal, graph a line. Where does it cross the y-axis? You guys got 25 and 27. Okay, so 27. Perpendicular bisector of segment CD has the equation of y equals 3x minus 11. If D is -3, what are the coordinates of C? Okay, so we have some segment that we don't know yet, and we have a graph of a line that bisects this segment, and we know one side is C and D we don't know, right? We're trying to find the other side of the segment given C and given the line. Okay, so we got to graph this. So we need to get an x and y axis. So you got to come up with your own here. So let's draw one. A straight edge is nice. 3x minus 11. Okay, so that means we're going 1, 2, 3, 4, 5. Okay, that's 5. -5. 6, 7, 8, 9, 10. Okay, -10. 1, 2, 3, 4, 5. So we're going down 11. Let's get a different color. So there's our y-intercept. Right there is -11. And our slope for this is 3/1. So that means we're going to go up 3/1, up 3/1, up 3/1, up 3/1. Just do a few times. Okay, there's a line. Now let's get the point C is at -3, 0 right here. So here's C. It's -3, 0. Okay, so we know that this, or just visualization over here, that these have to be perpendicular. So if we know this slope right here of this line is 3/1, we know the slope of segment CD has to be perpendicular, which means the slope is going to be negative and reciprocal, -1/3. So let's go down 1/3, down 1/3. Oh, we've hit the line. Let's keep going. And I'm going to draw a line here. Now, how do we know how far to go on this line? Well, kind of can see it visually, right? We know that if we go down 2 and over 6 to find on the point on the line, then we're probably going to have to go down 2 and over 6 right here. So this is going to be our point, which is at 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10 right here. So this is going to be at 9 and then -4. That's what it looks like. So we could use the midpoint formula. We know that the midpoint of the x values is the x1 plus x2 over 2. And we know that the y's are the average of the y's, right? So for midpoint. So we could say, okay, what is the midpoint of the x? It's right here. This midpoint is 3, -2. 1, 2, 3, down 2. So I could say the x here, x of the midpoint is 3. So I could say 3 equals x sub 1 here, let's call that negative 3. And x sub 2 is what I'd be looking for, is this one. Say we didn't know we wanted to do the algebra method. And so I over 2. Okay. And so I'm going to multiply 2 to both sides first to get rid of the divide by 2. That gives me 6 equals negative 3 plus x sub 2 plus, now I'm going to add 3, and then 6 plus 3 is 9. So 9 would be my x sub 2. And that's what we figured out here, 9. Same thing here with my y. I know that my middle for my y point right here is negative 2. y1 is 0. That's nice. y2 is what we're looking for, divided by 2. So multiply 2 to both sides. And I get negative 4 equals, I don't have to do anything with that 0. It's negative 4, right? There it is. So D, the answer is D is at 9, negative 4. Done. Okay, we're finished. Well, I am anyway. You still have 25, 11, and some other ones to do up here. But I hope that makes sense. And then you can give the challenge a crack over here. I might make a separate video for that one. Okay, everybody.